Hello everyone, my name is Patricia Foley and my partner's name is Jeff Morgan. I'll be going over Lab 2 for Big Data. There were two different parts to this lab. Part 1 dealt with Hive and Part 2 dealt with Solar. For Part 1, we were given a couple different databases that we could choose from. What we wanted to do was we wanted to create a table, upload the data from a database, and then perform 10 different queries on that data. For our part one, we chose the restaurant database. And as you can see, within this database, there's quotation marks. And within those quotation marks, we also have some commas. So we're actually going to have to create the table a little bit differently. And so let's get started. Let's create the table. And we're going to use this create table function where we specify the table name, and then we specify the different columns within that table, and we specify the data type for each individual column. And the difference that I want to point out is because we have those quotation marks and the commas within the quotes, we are actually going to use this OpenCSV, and this will actually prevent the data from being divided on that comma within the quotes and also remove the quotes. So that table was created, but I wanted to point out that even though we specified data types for this type of table, because we used OpenCSV, the data types were all converted to string. But that's okay for now. Let's go ahead and still upload the data from the restaurant database into this table. And to do that, we just use the load data command, and then we specify the path. And so the database for me is actually found in the downloads folder, and then you just specify the table. So once that data is uploaded into the table, we want to create a second temporary table. And the reason is because we need to convert the string data types into the data types that we want before we create our final table, which will contain arrays with that specific data type. So we created that table, so let's take the data from that temporary table, the first temporary table, and insert it into the temporary table 2. To do this, we'll just use the insert overwrite table, give the table name that we want to insert the data into, and then we're just doing a select all statement. So the data has been uploaded into the temporary table 2, and let's just check to make sure that the data types didn't change, and they haven't. So then let's create our final table that we're actually going to do the queries on. And as you notice, we'll have those arrays that are doubles and arrays that are strings. So let's insert the data from the temporary table into our new table. So one thing that I want to call out is instead of having the individual column longitude and latitude, we're actually creating this array here. It's an array of doubles. So this is a double and this is a double. And we're saving it as this new column, longitude, latitude. The same goes with this rating color and rating text. We're saving this string and this string as an array into a single column called rating. Perfect. And let's double check to make sure that we still have the table that we thought we created, and we do. So the next thing that we'll do is we will do our first of 10 queries. So for this query, we'll be using a select statement. That's, as you can see, that's how we start any query. And then the second part of a query is you have the column. You specify whatever column you want. So in this case, it looks like we have a lot of restaurant name columns that will be called out, and this will change slightly, the second column. But if you wanted to actually specify every single column, you just use an asterisk. And then you have this from statement, meaning which table are you actually pulling the data from. And then you have this where statement. And in this case, we have this where statement, and we have the aggregate rating is equal to 4.9. So the aggregate rating for us, 4.9 is actually going to be the highest aggregate rating. So I just wanted to see which restaurants had the best rating, and output not only the name but also the aggregate rating just to double check that our query was correct. And as you can see, all these restaurants scored the highest in that database. So the second query is we wanted to see where which restaurants served French cuisine. And to do that, since cuisine is a string, but as you can tell and hear, that string actually contains other words. It doesn't have to just be French. And so that's why we ended up having to search using this syntax, just to say, look for this word. I don't care what other words are there, but as long as it contains this word, I want to output that row. The next thing that we searched for was all restaurants that were located in London. To do this, we just simply said where city is equal to London. So these are all the restaurants that you can find in London that were a part of this database. The next one is going to see which restaurants had multiple locations. So if this restaurant name occurred in multiple locations in this database, it's going to count how many times this restaurant appeared, and then it's only going to output if the restaurant appeared more than 20 times. And it'll output the restaurant name and also the number of locations that it has based on this database. Okay, so as you can see, there's not a lot of restaurants that have greater than 20 locations, but as you can see, a lot of them look to be fast food restaurants, which kind of makes sense. So the next thing that we're going to query for is on price range. So price range indicates how pricey a restaurant is, 1 being the lowest, 4 being the highest. So by saying price range greater than 3, we just want all the restaurants that are the most expensive. And we not only want the restaurant name, but we also want the cuisine as well. So as you can see, all the outputs have for the price range, exactly what we queried on. So the next thing that we're going to query for is, say we're in London, so we want a restaurant in London, but we also really like French cuisine. So by using this and clause, we can search for both a city, the restaurant has to be located in London, and it has to be French cuisine. So in this case, there's actually only one restaurant that we can choose from, and it's restaurant Gordon Ramsay. So the next thing that we're going to be doing is this guy here. So the has table booking is actually a string, and has online delivery is a string as well. But what we wanted to do was we not only wanted to produce this name, but we wanted to create an array with this guy first, followed by a comma, and then this guy following it. But we wanted to specify that we wanted to have yes for being able to book online, and also yes to the online delivery. And as you can see, the array was produced. So if it had not worked, what you would have seen is you would have seen this blue water space yes space yes. But instead we wanted to have these combined to compress the data. The next thing that we queried for was, say you're in Century City Mall and you wanted to find what restaurants were available. This is the query that you would use. And it looks like if you were at that mall, you only had one option according to this database. So the next thing would be we wanted to find which restaurant had the most votes. And I wanted to output all the columns for that particular row. So in this case, the only one that is 10,000 or over was this restaurant right here. So lastly, this is similar to an if condition. So what we're going to do here is we're going to see where the aggregate rating is greater than 3.9. And then we're going to add this text, this string behind it, and it's going to say exceptional restaurant to the output. So it's going to say restaurant name, aggregate rating, and then based on that rating, it's either going to put exceptional restaurant, good restaurant, or it's going to have needs improvement. This is beneficial because it kind of groups more of these aggregate ratings closer together, because 3.9 to 4.9, you might not see that difference of a quality versus, say, if it's under a 2.9, the restaurant might need improvement. So as you can see, it looks like the query worked. It's 4.9, 4.3 is all above that 3.9. So all of these have that exceptional restaurant behind the restaurant name and the aggregate rating and then that text. And as you can see here, this 2.3, which is lower than that 2.9, it specifies needs improvement. So that's it for part 1. So let's close out of that and move on to part 2. So part 2 we'll be using Solr. So let's start by making a directory or generate a directory. And our database is actually going to be around dogs and different types of dogs. So one of the requirements was that we had to edit schema. There's different schemas that you can use that are already predefined, but in our case, we wanted to create our own schema. So to do that, we have to go into that config file and actually open up the schema. So this is the schema for this guy, and you just have to find where the different fields are already specified. So we'll just go in and we'll add our specific fields. So in this case, based on our database, we're going to have ID, breed, size, sex, family, and rescue as the different fields. So we're just going to specify in here, we'll just do field name, whatever the field name is, the type of the field, indexed, stored, required, and valued. And as you can see, we don't have any multi-valued fields. But once you are done editing this, just save it and close out of it, and you're on to the next step. And since we generated that directory and updated the schema, the next thing that we want to do is actually create this guy. And lastly, we just need to create the collection. Okay, so now that we've done that, we're actually going to go to this solar website, and we're going to make sure that we select the dogs too. I have a couple different dogs collections on here, but we're going to use dogs too, similar to what I specified here. The next thing is we're going to actually enter the data. So go to documents, and in this case we're going to use CSV for the data type and enter the data following the different columns. So we're going to submit that, and it looks like it's a success. So that's great. And now we're actually going to do a query. So just to check to make sure that our data actually was entered correctly, having an asterisk, colon, and asterisk means that we want everything. And we have 10 different dogs entered in here. And again, we see that there's a 10th row in our database. So we did get everything. So the next thing that we're going to do is we're going to keep the columns the same for all 10 queries. So we're just going to have the ID, breed, and sex outputted as the output. So the first thing that we'll query on is we want a dog that is female. So let's just do a quick search. And as you can see, there is only dogs that are listed as female are shown in the output. The next thing is if we wanted a dog between a certain size, so say 10 pounds to 50 pounds. So let's do a quick query, and these are the dogs that fit within that query. So the next thing that we'll be searching for is we'll want to find a dog that is either within the sporting family or the working family. So as long as sporting or working is listed, it should output. So in this case, it's Golden, Beagle, Pit Bull, and Mastiff. So the next thing that we'll query for is we'll use the AND clause where we're looking for a rescue dog, but we also want to make sure that the size is 50 pounds or greater. So let's do a quick query on that, and we only actually have two outputs there. The next thing that we are going to be looking for is let's do the opposite. Let's say that I don't want a rescue and I want a smaller size dog. So let's do a quick search, and as you can tell, Boston Terrier and Bulldog are usually a little bit smaller. So that query definitely worked. Query 6. The next query is so you want to have a rescue dog that is bigger than 30 and is not part of the working family class. So these are the outputs associated with that. The next thing that we're querying on is we're going to be using this negative again, and negative just simply means you don't want that. So for query 7, it's we do not want a rescue dog that is smaller than 30 or is not a part of the working class. So in this case, we're using an or statement for our query. And this is the output for that guy. So the next thing that we're going to look for is, so we want, in this case, we do want a rescue dog that is bigger than 30 and a female. Or we would be okay with having a working family dog if it was female. And that would be the outputs there. The next one is we're looking for, we don't want a dog that is a poodle and can either be a female or a bigger dog. So that's the output there. And lastly, we want a dog that is sporting and should be a female, or a bigger dog and not a poodle. And the only output would be the golden retriever. That concludes Lab 2. Thank you for listening.